Okay, coils are wound, and as you can see here, the lengths of this cut off. Actually, it's not even straight, but you pull that up to the top when you put it on, and you cut it off even. You bend this down like this. Now this is going to get attached to the power wires. So as you can see how that's going to work, I have to strip these down, each one of these wires, clean them, tin them, check continuity on the whole system before I put it together. So I'm going to clean all these wires. Now a lot of people use a torch, and honestly they don't go through any stress. So basically what I do is I just take a X-Acto knife, and some people say, well, you're going to nick the wire like that. If you hold it at a 90-degree angle to the wire, and it's a good and sharp one, you can scratch most of that stuff right off of the wire. Now I know a purist would say, well, that sucks, you shouldn't do it that way. Well, sorry, I wasn't never too much for being a purist. So basically, there you go. Now see, that's nice and silver, or copper. You can see where there's still coating on it if you look real careful, right there. So just real lightly drag this over it, and it'll clean up pretty good with just an X-Acto knife. And you can tell it's clean because when you go to tin it, it will be easy to tin. It'll stick to it really well. And that really, what that means is you got it clean enough. There are no gaps on it. If you look at look around the wire, you shouldn't see right there. There's a spot right there where it didn't come off. So it's like a plastic coating almost. And so you just hit it a couple times, take the soldering gun and touch it again, heat it up, and the solder should flow right through it. That way you got a nice clean surface to solder to the back of the diodes. So, alright, I'm going to go ahead and clean the rest of these like that, and then I'll go through a continuity check with you. One thing I want to mention here is the one that comes out of the center, you don't want to peel that back like the other ones. You just want to peel it back enough so you can clean these, because they need to be twisted back together. They look like this when they're finished, so they're all tied together, so you don't need to untwist that whole thing. Okay, we got all these cleaned, and even the little ones are tinned. So we're going to check continuity here to ensure we don't have a problem. So first thing you want to do is it is 2 ohms. The coil is 2 ohms, and by checking these other 2 wires, we're ensuring that we don't have a dead short somewhere inside across from one of these wires. You need these wires to not short out halfway through them, and then you don't get the full potential of the coil, and it's going to get hot. So that one's good. So I'll check every one of them like that. And we already know it won't have continuity to that other one because we checked it. So there we go. Power wires are good all the way through. No issues with shorts. Let's check the small wire. Trigger wire. Trigger wire is 6 ohms. So the main coil is 2 ohms and the small coil's 6 ohms. Now I just want to say right here, it doesn't really matter, because the way this works is they're individually being pulsed. Each one contains its own trigger. So by that fact, it doesn't matter if they're balanced. Like normally if you had a pulse motor and all the coils were firing at the same time, the ohmage would have to be perfect. They would match, or else one of them is going to push harder than the other one. And actually could waste the whole energy of one of the coils, because the coil's firing but it's not pushing, and it's like right behind the one that is pushing. So basically it's like following a truck down the highway. You know, you're in its draft. It's firing, it's using energy, but it's not pushing effectively. And the sequential concept eliminates that problem, because they're not firing at the same time. They're firing, you know, milliseconds ahead or behind each other. They're past that initial power curve. So that way we all get a push out of all of them. And you're able to adjust it slightly to ensure that you are not in the wake of another in the coil draft. Let's just call it a coil draft. In the coil's draft with the other coil. So, alright, all these are good. So the next step here is to, this is the way I do it. You can do it however you want, but what I do is I take these the ends that are going to go on the chip, the diode set, I bend a small hook, as small as I can make, and then bend it to the side, like that. So that right there means I can hook it underneath the diode on the back of the circuit board, right here, right, because we're going to fold this over like this. And that's going to hold it in place so I can solder it to the diode pack. So I already got one of those set up like that, so I'm not going to wait on it. So we're going to hook this onto the diode pack. And this wire right here has just been twisted together and soldered together. Where it was like this when we checked it. These were all twisted back together tight, and then I put a eye hook and crimped it like that, and then soldered it as well. So that is my hot. That's where it's feeding the energy back to the chip, because it's flowing from the positive to the negative, and the negative's being triggered. So that's the way you want to do that end. So, alright, I'm going to go ahead and hook these on, and I can show you what I'm talking about here. So basically what we're doing, slide this under it, and you might have to pry it up a little bit. Right. So we slide that right under, and as you can see right there, it really makes it easy to solder by doing that. So make a liar out of me. Okay, so see, that's ready to solder right there. So I'm just going to hit that. Make sure that we got a nice, good, solid solder connection there. So, alright. So if the energy hits that spot, as it's collapsing, the energy's bounced back to the collection plate that goes to the other batteries. Well, normally that would generate a back EMF spike. It's being collected. Now, it's still, actually, the Bedini can create a back EMF if it's like right on top of the magnet, because it doesn't have enough time to react. I just hooked the wire around where it comes out of the center of the chip and comes through the back, and then it's soldered to the diodes, the 6 diodes, to the collector plate. So the wire for the coil gets soldered right at the base of that. I just create a little hook it on there, and then it's simple enough to hit it with some solder. Alright, I hardly got a tip. I've been doing a lot of soldering, so normally you'd see that a lot better because the tip would be there, but unfortunately, there we go. Heat it, make sure it's melted good to the rest of it. So there you go. Okay, now once you got those soldered, you're going to bend this down out of your way, and then you're going to fold this over and tighten these two bolts down. Alright, so now we got those tightened down, the board soldered. This is going to get soldered to there. This gets put in there. As you can see here, we attached this wire to the ground plane right here, and then this wire goes to the ground of the motor. So I'm laying it right there too, and I'm going to solder that. I know that's kind of confusing. I really don't know how to show that any other way than up close. I'll give you a wide shot, but what you're doing here is you're connecting those ground wires together to all the chips and connecting them to the external ground. Is what the best way to describe that. Okay, what we want to do is heat that up. I put the wire in there because the wire just barely fits in this connector. You could tin it and put it in there if you wanted. So I really got to get this thing hot in order to get that solder to melt inside that connection there. So I'm feeding it from both sides here. It's a little hard to see, but we want to ensure that it's sucked in. You can see there's the ground wire, system ground, and then the positive, and then the return wire. So the control board's all put on the back here. So we got the control board on the back. So that's one complete coil right there. Got a few more down here. So I get 6 done. I only got one more to do, and I'll be able to put them all on the small box motor. The rest of the coils back there are for the large box motor. So cooking right along. Okay, so this could be done with a metal strip as well. Has to be a good conductor, because as you can see, I'm soldering them to the wire. And they're anchoring the wire, and they're also providing a mounting point for the input wire or the output wire, depending on which side of the motor you're looking at. So both of them have a number 10 wire all the way around. And then the ground wire is going to be a lot smaller. You got to remember, the way this works is the energy is passing from the positive through the coil. It's pulsed, and then it's on the output. So the positive on the input side and the output of the coil are being used as the output feed. So like a classical Bedini motor, the ground is really just a point for the trigger to handle. It's not part of the loop of the energy passing through the motor. So the wire can be a lot smaller. I'm going to use these little clips here, and then the ground wire is going to get connected to there. That way, if I want to kill any one of these coils, I can just pull the ground wire and I can individually test the coils. Because it's not just about building a motor that works, it's about being able to fix the motor if something goes wrong. So I try to build these systems in place that allow me to make changes to it fairly easy without doing a lot of unsoldering and stuff. So basically what we have here, I digress, is a metal strip. It's copper coated with this silver coating, not real silver, but, and what I'm doing is I'm taking it and I'm bending it over like that, so you can see that, and then I'm squishing it down against this drill bit that's the same size as the number 10 wire. So I'm squishing it like that. Then I'm bending it up a little bit so it'll lay flat. So what you have after that is something similar to this. So we want it to go over at a right angle, so we're going to take it and bend this down like that. And that's what I'm making right there. Now you might be able to buy something similar to that, but in this case that's what I'm doing. And then I'm notching the wire. I'm not cutting the wire, I'm just taking the coating off, the outside coating off, and then soldering the connection to the wire and mounting it. An easy way to do that in this case is just to take the wire and take an X-Acto knife and just go around it fairly quick. You got to be careful here. I don't want to get anybody hurt. I do this stuff a lot, and I've got pretty proficient at using this. So you be extra careful when you're doing this kind of stuff because you could easily cut yourself. So. Let's see, we just take that, peel off the jacket of the wire, and that exposes the copper. And then I'm taking this new connector, connecting it through that, like that, drill and mount this. Do here. So we want to heat this. I'll have to do it so you can see it here. I'm going to heat this up so the solder melts into the copper wire. Now the jacket has to be hot enough for it to be saturated, so you want to make sure it's melting to the copper wire at the core and not just to this little connector. So you want to make sure that's good and hot. And once you think you got enough solder in there, trying to make sure it's good and hot before I pull it away. What I do here normally is I heat this up to the point where I know that wire is hot enough, and once it's to that point, I just put something against it so it can cool and still be attached properly. And that's how I'm making these connectors. Now this is going to make the design a lot easier because your two major wires, your input wire at 120 volts and your output wire, are both run around the inside of this frame. And if you remember on the cart motor, you can see over there, it was a big large harness that had to run around. And this is going to simplify the design considerably. So this will be like this on both sides, and the ground will just run kind of on the inside from one coil to the next, because it's only grounding the chip gate is all that's really it's being used for, is for the trigger circuit, because the current is flowing from the positive on this side to the output on the other side, and they're both being tied together and generating an output. So the ground actually is terminated from the high side, from the 120 volt side. It basically is just adding that ground potential for the trigger. So it doesn't need to be a big wire. It'll probably be something this size right here. I think I can get away with that. And if I don't, then I'll update this video and you won't see this wire. So